We're looking at transformations of log. This is the general form of the transformation of log equation. There's lots going on there we'll talk about in a bit. First, write it down. So pause this, write it down. Great. If you're watching, that means that you've written that down. And now if you want to, and you do, write this stuff down. So it says SF6LEZNG7Z. If you write that right here, right over the calculator, then this whole page, this stuff will just show up, and then you can start playing around with it and seeing what's happening and following. So my recommendation is you watch this through, you take notes, then you go back, plug this into the website, this number right here, this letter number thing, plug it in right here, and then you can manipulate it and see and play and understand for yourself what's happening. That's my strong recommendation. Great, so now let's get started. The first thing that we'll look at is the most basic. It says blah, 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 plus k. Well, we know from all of our transformations that what's happening is k is going to move it up and it's going to move it down. So let's just watch that happen. Okay, so here it is. K is moving this up. And speed that up. And k is now moving it down. And k is moving back up now because it's positive. And now k is moving it back down. So as you can see, the k changes the y values. It's moving this function up and moving this function down. So let's go back and just look at k equal to 0. Now let's look at the next most obvious thing, which is it says x minus h. Well, you guys remember that if it's like x minus 3, then that would be moving it to the right 3. And if it's x plus 3, it'd be moving it to the left 3. So let's just watch that happen in action here. And let me just pause this. Notice that it's negative and it's moving to the left. If you're confused about that, it's because this function is saying x minus a negative 6.9 and x minus a negative is a positive. So in other words, what's really happening is this is like writing x plus 6.9. So it's still moving to the left. Moving to the left, moving to the left. And once we get positive, there it is. Now it's moving to the right again. To the right, to the right, to the right. A little bit of Beyonce, to the left, to the left. There we go. So we know exactly what's happening with that. Now, what you might not have noticed is usually when h is 0, we have this asymptote at x equal to 0. It's a vertical asymptote at x equal to 0. Take that down. Vertical asymptote at x equal to 0. The way to get the asymptote here is by simply writing down whatever x equals, or h equals. So if h is 7.6, then the vertical asymptote would be at a negative 7.6. Let's see if we can click on one of these things. Nope. Well, this is like at a negative 7.6 or so. If h was a negative 5, we can see the vertical asymptote is x equal to a negative 5. X equals to a negative 5. If h is 3.6, 2.6, here it is, 2.6, then the vertical asymptote is x equal to 2.6. If h is 6.1, then the vertical asymptote is x equal to 6.1. So in other words, take that down, x equals to h is the vertical asymptote. So take the stuff that's in the parentheses, set it equal to 0, just like you're finding a root, and you get x equals h. That is the asymptote. That's your vertical asymptote. All right, let's change this back to 0, and look at what happens when the base changes. So remember, this is like saying log base. Right now it's log base 2, log base 2, log base 10, log base 0.5. Let's just see what happens. This is what's changing the actual graph. So when b gets bigger, it compresses the graph, or it stretches it out. It makes it wider. When b is smaller, when b is smaller, you notice that it was starting to get a little bit taller, a little steeper. And then when b is between 0 and 1, something else is happening. So notice what's happening between 0 and 1. I'm not talking about when the graph disappears. That's a different thing. And to contrast that, let's look again at what happens between like 1 and 4. So 1.1 and 4. So when the graph, when b is positive and greater than 1, the graph looks like the way that my arrow is showing. Right? It just looks like this. But when it's a fraction, when it is a fraction, and it actually looks like this. So remember, when b is positive, look at my cursor, it goes like this. When b is positive and greater than 1, when b is between 0 and 1, so like a fraction or a decimal, it goes like this. So fraction and a decimal looks like this. And between like 1 and 4, or 1 in a million, it looks like this. Good. So the last piece to look at is the a. In the last video you watched, you saw what a did to the exponential function, and you should be expecting the same sort of thing to happen here. It's making it more narrow, it's making it taller when a is greater, it's bigger when a is getting smaller, it gets flatter, and then when it gets negative, it does just what you think. It reflects. It reflects over the x-axis. And it starts to look a bit like this. Flex over the x-axis. Watch what happens when it gets positive again. There it is. It flips over and begins to look like the normal log function. Pause this video and take down all of those notes. If you haven't taken down all of those different components, you'll want to re-watch this and take those notes again. When you press play, we'll be looking at some practice problems. Now we're going to look at these functions here. So there's actually 8. And you want to take them down, as always. Make sure you copy them exactly. And I've changed this link too to include all of these functions. So if you want, you can follow along, and then you can type this in, which is much easier. N, D, Z, N, B, E, S, B, E, S, T, B, S. Anyway, you guys can read it right there. So copy these 4 down. When you're done with that, press play again, and we'll look at them. Have you copied them down? Have you actually copied them down? Good. So what we're really looking at, notice there's no H, there's no H, there's no K. So we're not looking at moving the function up and down. We're not looking at moving left and right. This is more about shape. Does it look like this, or this? This is You should notice this is just like a normal log function. It's got a positive coefficient, a positive greater than 1 base, and so that's just what we see. We see a log function that's growing a little faster than normal, and that's it. So it'll look like this. When you're ready to move on, click play. This one is the negative of that one above it. So it's just going to be flipped, and it's going to be flipped across the x-axis, or reflected across the x-axis. That's what this negative serves to do. Now let's look at these next two. It's 3 times log base of 1/2 of x. 1/2 of x. Let's see what happens there. So again, this is, it's like if it was reflected from this original one over the x-axis. And then lastly, it's a -3 log base 1/2. So let's look at that. And just like in the exponentials, when we have a negative coefficient here, and then we have a fraction as a base, then we see that it ends up looking just like the original logarithmic function did. So a negative and a fraction makes it look just like it did before. Copy these 4 down. When you're ready, press play. Great, so we're going to look at each one of these. I'm just going to click them, so as soon as you've checked your work, press pause again so that you can sketch it, check your work again, and so on. So 1/2 times log base 3 of x looks like this. And -0.5 log base 3 of x looks like this. Going to uncheck both. When you're ready, press play. Take notes. When you're ready to press play. Okay, at this point, you'll want to summarize all of the things from this lesson. So we know that k moves the function up and down. We know h moves it left and right. And we know that a makes it get steeper. When a is negative, it flips over. So let's look at what happens with that again. So here it's positive. Here a is negative. And we see that it reflects across the x-axis. Great. See you guys tomorrow.